Okay, let's show you a demo of SimSolid. What I'll try to do today is do this analysis of this cube satellite, but I'll do it in a couple ways. I'll do two load cases, and then I'll also look at three design variations. And let's just see how fast we can get this done. When you get to SimSolid the first time, you have to open up a CAD file. You have a couple ways to do this. You can just, as standard products go, you can pick open and then go to the different CAD formats, CATIA, NX, or, Parasolid, SolidWorks, Creo and Pro-E, JT, Inventor, etc. So you can bring in geometry that way. Or you can get geometry through Cloud Access. And we have this little convenient cloud button here. Let's start there. So I'll pick Cloud. And I can connect any cloud data store that I have access to. In this case, it's Onshape. But let's go and grab my CubeSat here. And let's grab that first variant we discussed, variant A. Okay, I'll go to the cloud, grab the geometry. It'll load it. Now, a couple of things will happen. First thing it does is it loads the geometry and prompts you to create connections. You need to specify a couple of things. First, the gap tolerance, the penetration tolerance, and then the resolution of the contact. So I'll just do this, and I say OK. And that'll create all the connections automatically. Now, the CubeSat model that we have is an assembly of, about 24 parts. And you notice these parts already have material properties assigned. Some of our CAD interfaces, including Onshape, will bring in both geometry and material properties. Not all, but you can, if you don't have your properties assigned, you can just go to Assembly, pick this button here, and you can pick the different materials that you want, as well as you can apply them to all parts in the assembly or just apply them to selected parts. I won't do that here. Okay, I have my assembly. I have all my connections created. So the next thing I need to do is do an analysis. I come up here and I pick what type of analysis, structural, linear, nonlinear, modal, dynamics, etc. Let's do initially a structural linear. And let's just constrain the base. And let's just pick maybe these four faces. 1, 2, 3, and 4. And let's just apply a simple unit load to one of the tops. So I just say unit load. I'll pick here. I'll make it maybe -1 Newton and Z. Okay. And now I'm done. I don't have to do any meshing, so I just hit this button to say Analyze. Now, as it's analyzing, as I mentioned, it's an adaptive solver, so it solves it multiple times, 1, 2, 3, and gives you a result. So it's done. I can look at things like displacement magnitude. I maybe want to animate that. Maybe I speed it up a bit. And if I want to save any view for later reference, I just hit this little bookmark button here, and it'll save that image and animation into a bookmark, and I can go back to it later. So maybe I want to stop that. Let's look at maybe stresses. Okay, there are my stresses. Let's bookmark that. Let's stop for that variant. But what happens now if I want to examine what happens when I change my model? Let's go back to the CAD source. And again, this could be any CAD source. I can go to Onshape, or I could go to NX or Creo or whatever. But I'll just go grab a different design variation. Let's get variant B. We'll open that. Now, a few things different will happen this time. First, it recognizes that as a design variation, and it copies it into a new design study. And then it copies down all the analysis boundary conditions that were defined above and make them all ready to go. So I have my two structural load cases on this new geometry. There's geometry 1, there's geometry 2. And to run geometry 2, let's just pick the root of the design study, and then picking it here, we'll say run all analysis in that design study. So it's running this bold one here, that's analysis case 1. and then here it runs analysis case 2. Okay, so what I've done now is I've had 4 analyses completed, and they're all adaptive solutions, and they're for 2 completely separate geometry variations. So there's analysis 1, and if I want to go to analysis 2, just pick here. I can go back and forth again very quickly. So the idea is okay, I want to do a design variation and examine how the performance changes. There's, again, load case 1 or load case 2, etc.